Betelgeuse is acting strange. Are we about to witness a supernova? Get ready to witness a potential cosmic event that could change our view of the night sky forever. Betelgeuse, a massive red supergiant star located in the Orion constellation, is behaving in a way that has astronomers both excited and deeply concerned. Recent observations using the powerful James Webb Space Telescope have revealed unusual signals coming from this colossal star. Even physicist Brian Cox has issued a stark warning. The big question on everyone's mind: is Betelgeuse about to explode? A giant star nearing its final moments. Betelgeuse isn't just any star. It's an aging giant, about 900 times the size of our Sun. If placed at the center of our solar system, its surface would extend past the orbit of Mars, swallowing up Mercury, Venus, Earth, and the Red Planet. This immense scale hints at its current stage in stellar evolution. Betelgeuse is in the red supergiant phase, a period near the end of a massive star's life. Having burned hydrogen in its core long ago, it's now fusing heavier elements. At around 8 to 8.5 million years old, Betelgeuse is considered ancient by stellar standards. Over that time, it has changed dramatically, both in appearance and behavior. Why is Betelgeuse red? The red color of Betelgeuse comes from its relatively cool surface temperature, around 3,500 Kelvin, compared to our Sun's 5,500 Kelvin. Cooler stars emit light in longer wavelengths, which is why Betelgeuse shines with a reddish hue. Interestingly, historical records suggest its color may have changed over time. Ancient texts from Roman and Chinese observers described it as yellow around 2,000 years ago. Later, in the 9th century, Arab astronomers referred to it as red, supporting the idea that Betelgeuse has evolved significantly in human recorded history. A star that pulses with mystery. Betelgeuse is known as a variable star, meaning its brightness regularly rises and falls. It has two primary brightness cycles, one lasting about 400 days and another much longer, spanning around 5 years. But what makes Betelgeuse different is its unpredictability. Sometimes it dims in ways that don't follow the usual pattern, hinting at complex activity inside and on its surface. One of the most dramatic examples happened in late 2019, in what became known as the Great Dimming. The Great Dimming, a cosmic puzzle. At the end of 2019, Betelgeuse began to fade unusually fast. Its brightness dropped at a rate of 0.1 magnitude per day. By early 2020, it had become so faint that people could notice the difference with the naked eye. For a star that usually stands out clearly in Orion, this was a major event. But there's a twist. Betelgeuse is about 654 light-years away. That means any changes we observe now actually happened over 6 centuries ago. This time lag adds a layer of mystery to an already complicated phenomenon. Hubble reveals the cause. To understand what caused the Great Dimming, scientists at the Harvard-Smithsonian Center for Astrophysics, led by Andrea Dupree, began a focused 3-year observational campaign. Using the Hubble Space Telescope, they studied Betelgeuse's outer layers in ultraviolet (UV) light, something ground-based telescopes can't do. What they discovered was stunning. Hubble's spectroscopic instruments detected massive outflows of gas being ejected from the star's surface at speeds close to 200,000 miles per hour. This material traveled millions of miles before cooling and forming a dense cloud of dust, which temporarily blocked part of the star's light from reaching Earth, explaining the sudden dimming. A warning sign, or just a phase? The amount of material ejected from Betelgeuse, especially from its southern hemisphere, was far greater than expected. This sudden and intense mass loss raised concerns among astronomers. Could it be the beginning of a supernova? While the possibility is intriguing, many scientists urge caution. Massive stars like Betelgeuse can go through dramatic phases like this thousands of years before they actually explode. Some experts suggest that what we're seeing could be the result of large-scale convection patterns, sudden dust formations, or other internal changes. If Betelgeuse explodes, imagine walking outside one day and noticing a new star in the sky, so bright it casts shadows on the ground at night, and visible even during the day, rivaling the brightness of the full moon. That's not science fiction. That's what would happen if Betelgeuse, the red supergiant, suddenly goes supernova. In the blink of a cosmic eye, its core would collapse, triggering a massive explosion that would send shockwaves of light, radiation, and matter into space. For astronomers, it would be a once-in-a-civilization opportunity to witness the final death throes of a massive star. Something that hasn't happened this close to Earth in modern human history. The supernova would release 1 billion times more energy than our Sun emits in an entire year, producing high-energy neutrinos, X-rays, gamma rays, and intense visible light. These particles would travel across space, reaching Earth centuries after they were first emitted, an echo of a violent cosmic finale. But here's the stunning part. Despite the raw power of the blast, Earth would remain completely unharmed. At a safe distance of 654 light-years, the light and radiation would pose no threat to life. There would be no physical impact. Only a celestial firework, a light show visible to every human on Earth. The night sky would be transformed. For months, Betelgeuse would outshine every star. Artists, poets, scientists, and ordinary stargazers would turn their eyes upward, united in awe. It would be a global moment, one of rare beauty and profound scientific importance. A scientific treasure trove in the event of a Betelgeuse supernova. Telescopes worldwide would capture every second of the explosion in multiple wavelengths, from radio to infrared to gamma rays. Instruments would measure how the star's core collapses, how neutrinos escape, and how the shockwave propagates outward. Astrophysicists would gain first-hand insights into processes that, until now, have only been simulated in labs and supercomputers. We would finally understand how elements like gold, uranium, and iodine are forged in the crucible of exploding stars, the building blocks of planets, life, and everything we know. A visible supernova of Betelgeuse's magnitude would be more than a headline. It would be a defining event for modern astronomy. The mystery remains, but for now, Betelgeuse holds its secrets. This brilliant red supergiant continues to pulse and flicker with unpredictable rhythms. Its surface ripples with massive convection cells, bubbles of gas the size of Earth that rise and fall in slow, boiling motion. Its brightness fluctuates, sometimes gently, sometimes violently. It sheds enormous clouds of dust, only to glow brightly again. Is this normal behavior for a dying giant, or the calm before a stellar storm? Despite decades of close study, we still don't know. Is Betelgeuse simply aging in dramatic fashion, or is it preparing for a final, unstoppable collapse? Recent dimming events, such as the Great Dimming in 2019, hinted at something unusual. Dust clouds? Surface disruptions? Or early signs of collapse? The James Webb Space Telescope, Hubble, and a global network of observatories remain locked onto Orion, watching every flicker and pulse. Scientists analyze UV spectra, track mass ejections, and simulate supernova conditions in virtual models. But Betelgeuse doesn't follow our rules. A waiting game across time and space. There's a poetic truth about Betelgeuse. What we see now already happened centuries ago. The light reaching our eyes tonight began its journey over 650 years ago, long before telescopes, before electricity, before recorded science. If Betelgeuse has already exploded, we won't know until that light finally reaches us. And so, humanity waits, on the edge of discovery, staring at a giant star glowing in Orion's shoulder, wondering if the next blink will be its last. Whether it explodes tomorrow, in 1,000 years, or not for another 100,000, Betelgeuse reminds us that the universe is always in motion, always changing, and that we are lucky just to witness a fraction of it. One star. One mystery. One moment that could light up our world.